Distance formula to find the distance between two coordinate points P x1 y1 and Q x2 y2 is root of x2 minus x1 whole square plus y2 minus y1 whole square. And if one of the point is the origin, then the formula is OP equals root of x square plus y square. Suppose we cut this distance into two sections in a certain ratio, can we be able to find the coordinate of the point of division? Let's check it out. For example, if point P divides the line segment AB in such a way that the distance from A is twice the distance from B, that is, if P divides line AB in the ratio 2:1, so AP by PB equals 2 by 1. Considering this in the xy plane, and since we already know the positions of A and B, say 0, 4 and 8, 1 respectively, we need to find the coordinates of P in such a way that P divides line AB in the ratio 2:1. Let the coordinates of P be xy. Draw perpendiculars from P and B to the x-axis, meeting it in E and F respectively. Draw PC perpendicular to PD and BD perpendicular to BF. According to AA similarity criterion, if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. So triangle ACD and triangle PDB are similar. Therefore, CD by DB equals AP by PB equals 2 by 1 and AC by PD equals AP by PB equals 2 by 1. From the figure, we can understand that OE equals x units and OF equals 8 units. Also, OA is 4 units, OC is y units. So CD equals x and DB equals 8 minus x. AC equals 4 minus y and PD equals y minus 1. So x by 8 minus x equals 2 by 1 and 4 minus y by y minus 1 equals 2 by 1. Upon further calculations, we get x equals 16 by 3, that is 5.33, and y equals 2. So the coordinates of P are 5.33, 2. Now that we have understood this concept, let's formulate this. Consider any two points A x1 y1 and B x2 y2 and assume that P xy divides AB internally in the ratio m1:m2. So PA by BP equals m1 by m2. Draw AR, PS and BT perpendicular to the x-axis. Also draw AQ and PC parallel to the x-axis. Then by the AA similarity criterion, triangle PAQ is similar to triangle BPC. Therefore, PA by BP equals AQ by PC equals PQ by BC. Let's consider this as equation 1. Now, AQ equals RS equals OS minus OR, which is x minus x1, and PC equals ST equals OT minus OS, which is x2 minus x. Also, PQ equals PS minus QS equals PS minus AR, which is y minus y1, and BC equals BT minus CT, which is equal to BT minus PS, which is y2 minus y. Substituting these values in equation 1, we get m1 by m2 equals x minus x1 whole divided by x2 minus x, which is equal to y minus y1 whole divided by y2 minus y. Taking m1 by m2 equals x minus x1 divided by x2 minus x, we get x equals m1 x2 plus m2 x1 whole divided by m1 plus m2. Similarly, taking m1 by m2 equals y minus y1 by y2 minus y, we get y equals m1 y2 plus m2 y1 whole divided by m1 plus m2. So the coordinates of the point P, x, y, which divides the line segment joining the points A, x1, y1 and B, x2, y2 internally in the ratio m1 is to m2 are P, xy equals m1 x2 plus m2 x1 whole divided by m1 plus m2, m1 y2 plus m2 y1 whole divided by m1 plus m2. This is known as section formula. This can also be derived by drawing perpendiculars from A, P, B on the y-axis and proceeding as above. If the ratio in which P divides AB is k is to 1, then the coordinates of P will be Pxy equals kx2 plus x1 whole divided by k plus 1, ky2 plus y1 whole divided by k plus 1. If P is the midpoint of AB, it divides in the ratio 1 is to 1. Therefore, the coordinates of the midpoint P of the join of the points A, x1, y1 and B, x2, y2 is Pxy equals 1 into x2 plus 1 into x1 whole divided by 1 plus 1, 1 into y2 plus 1 into y1 whole divided by 1 plus 1, which is equal to x2 plus x1 by 2, y2 plus y1 by 2. Now let's work out a problem. In what ratio does the x-axis divide the line segment joining the points 2, minus 3 and 5, 6? Also find the coordinates of the point of intersection. To understand this better, let's roughly plot these points on the xy plane. Given the x-axis divides the line segment joining the point say A, 2, minus 3 and B, 5, 6 at P, x, y in the ratio m1 is to m2. For our convenience, let's consider the ratio m1 is to m2 as k is to 1. So, we just need to find the value of k, which may be a fraction form and can be considered as the ratio. Then the section formula Pxy is Pxy equals kx2 plus x1 whole divided by k plus 1, ky2 plus y1 whole divided by k plus 1. Substituting the values of a and b, we get Pxy equals 5k plus 2 whole divided by k plus 1, 6k minus 3 whole divided by k plus 1. Since Pxy is on the x-axis, the coordinate of y is 0. So, 6k minus 3 whole divided by k plus 1 equals 0. On further calculation, we get k equals 1 by 2. So, the required ratio is k is to 1 equals 1 by 2 is to 1, which is 1 by 2 or 1 is to 2. Substituting k in the x coordinate of P, we get x equals 3. So, the x-axis divides the line segment joining A, 2, minus 3 and B, 5, 6 at P, 3, 0 in the ratio 1 is to 2. So, we can conclude that section formula is to find the coordinates of the point Pxy, which divides the line segment joining the points A, x1, y1 and B, x2, y2 internally in the ratio m1 is to m2, and it is Pxy equals m1 x2 plus m2 x1 whole divided by m1 plus m2, m1 y2 plus m2 y1 whole divided by m1 plus m2. If the ratio is k is to 1, then it is kx2 plus x1 whole divided by k plus 1, ky2 plus y1 whole divided by k plus 1. And if the ratio is 1 is to 1, then it is x2 plus x1 by 2, y2 plus y1 by 2.